Okay guys and girls, so today what we're going to be looking at is displacement reaction of group 7 elements. Now if you haven't seen this channel before, my name is Mr. Hader and I'm going through all of the GCSE curriculum. I'm currently doing chemistry, then I'll go on to do physics and then biology, and this is to the AQA standards. Okay, so by the end of today's lesson you should be able to know whether or not a reaction will take place. Okay, so if you look at this table here, right, if you look at this table here, we've got our halogens, and if you remember from the last tutorial that I did, you've got fluorine, chlorine, bromine and iodine. Now the halogens end in INE, right, so they are INE, and here we have the halide. So an example of the halide would be potassium fluoride, right? So here is my halide. So for example, this could be potassium fluoride, it could be calcium fluoride, it could be sodium fluoride, but just to give you an example, we'll go with potassium fluoride. So our halides are potassium fluoride, potassium chloride, potassium bromide and potassium iodide. And if you notice, halides end in IDE. So by the end of this tutorial you should be able to fill this table in as to whether there will be a reaction or no reaction. So today we're going to be looking at group 7 elements, which are all of these. Now if you remember from the last tutorial, the most reactive halogen is the one you just can't F with, which is fluorine. So fluorine is the most reactive, with the least reactive being right at the bottom. This is the least reactive. Right, so what that means, if we were to put this into context of a formula, if we have, for example, potassium bromide, so this is the halide, remember, so it ends in IDE, and we're going to react that with, for example, chlorine. The question is, number one, can chlorine displace this bromide bit? So to think of it as a bully analogy, the question is, can this chlorine here bully this bromine here? And the answer is yes, because if you remember, the ones at the top are more reactive than the ones at the bottom. So this chlorine can bully the bromine and take its place. So what we're going to have, because the answer to that question is yes, it can bully, if you like, it is more reactive than the bromine within the periodic table, so that's going to kick out the bromide, and you're going to have the following occur. So potassium bromide plus chlorine is going to make potassium chloride plus your bromine on its own. Now can you see this becomes the IDE because it's now a halide, and the bromine becomes a halogen once again because it's on its own, and so it ends in INE. Whereas here this is the ide because it's with potassium, and this is the INE because the chlorine, the group 7 halogen, is on its own. So let's do another one. For example, let's go with potassium iodide. So now remember, it's IDE because it's a halide, and let's say we're going to react that with bromine. So bromine is on its own, therefore it ends in INE, and the question we're asking ourselves is, number one, will there be a reaction? So if you look at the periodic table, we've got bromine, and we're asking, can it displace the iodine? Well, because bromine is higher up than iodine, bromine is more reactive than iodine. So it's more reactive than iodine, therefore the reaction can occur. So bromine is going to kick out iodide to make potassium bromide plus your iodine. So because iodine is now on its own, it ends with INE. So let's do one more example. Let's say, for example, we have let's go with potassium fluoride, so plus chlorine. Now the question becomes, can chlorine displace the fluorine? Can it bully the fluorine to take potassium off it? And the answer is no, it can't, because remember, potassium, the fluoride is the one you cannot F with, and so fluorine is going to stay where it is, and chlorine cannot displace the fluoride. So can it occur? No reaction. Why can it not occur? Because the fluorine is more reactive than the chlorine. So it's all about can these halogens kick out the halide? That's really what you're asking. So one more, just to illustrate that example. Let's say we've got potassium. Now guys, I'm using potassium. It could be sodium chloride, it could be sodium, it could be calcium, it could be any type of halide, but I'm just using potassium, right? So let's say potassium chloride reacts with bromine. Again, I want you to notice that when the halogen is on its own, it's INE. When it's as a halide reacted with something else, it's IDE. So if we have that occurring, the potassium chloride plus the bromine, can the bromine, the question is, can the bromine kick out the chloride? And the answer is no, because chlorine is more reactive than bromine. So here we've got no reaction once again. So can you see how important it is to use your periodic table? So the final point, I suppose, is how do we put this into a chemical formula? So let's take one. Let's say potassium bromide plus, so we want a reaction to occur. So if potassium bromide is here, right, which element is able to displace this potassium bromide? Well, it's anyone that's above. So we'll react it with chlorine. So potassium bromide plus chlorine is going to make potassium chloride, so it did displace it, IDE, remember, plus your bromine, which is going to be on its own, which is INE. So what we can do here is, we know from ionic equation, this is K plus because it loses an electron, this is Cl minus. If you swap the numbers over, it's a 1-to-1, so it's going to be KBr. If you haven't seen that tutorial of mine, go check it out. Plus it's on ionic equation, so we've got KBr, that bit's done. We've got chlorine. Now as we said in the last tutorial, all halogens when they are on its own are diatomic. So we've got KBr plus Cl2. Why that 2? Because group 7 are diatomic. So what's that going to make? Well, it's going to make potassium chloride, and again it's KCl plus bromine. So bromine is now on its own, so that is going to be Br small 2, because remember, group 7 when they are on their own are diatomic. Now we got to just check if they are balanced. So we've got one potassium here, one potassium here, so far that's balanced. We've got one bromine here, but only 2 bromines here, so we need to balance this. Right, so now we've got 2 bromines. Our bromines are balanced, so I can tick those off. Next, I've got 2 potassiums here, but only 1 potassium here, so I'll put a 2 there. And that will mean that I've got 2 potassiums here, 2 potassiums there, so I'm going to tick off my potassiums. And my chlorine, I've got 2 here and 2 here, so I can tick that off. It's all nice and balanced. Let me do one more and see if you can do it yourself. So I'll give you the word equation, pause it, see if you can do it yourself. Okay, so it's going to be, let's see, potassium iodide plus let's go with fluorine is going to make, now number one, will a reaction occur? So can we steal this by using fluorine? Yes we can, because fluorine's more reactive, and so it will displace the iodide. So we're going to have potassium iodide plus fluorine, which makes potassium fluoride FLUORIDE, remember, because now it's a halide, plus your iodine, which is on its own. So let's now construct the chemical equation. So it's potassium iodide, which is Ki, right? And remember, just to go through it, this has a positive charge because it's going to lose an electron. This has a negative charge because it needs 8 maximum. So if it gains 1 electron, it's going to have a negative charge. You swap the numbers over. In this case, it's 1 to 1 anyway, so it's just K is going to 1 and I is going to be 1. Again, check the ionic equation tutorial. So fluorine is on its own. It's a group 7, so it's diatomic. So we need F2, which is going to make potassium fluoride, which is KF, plus iodine, which is on its own, which is going to be diatomic therefore because it's group 7. And now all you have to do is balance it. So I've got one potassium, that's okay for now. I've got one iodine molecule here, and I've got 2 here, so I need to balance that with a 2 in front of this. So now I've got 2 potassiums, and well, let's do that. So I've got 2 iodines, so tick that off. I've got 2 iodines here, so I can tick that off, that's correct. I've got 2 potassiums here, but only 1 potassium here, so I need to put 2 there. So now I've got 2 potassiums here, and I've got 2 potassiums here, so that's correct. Let's check the fluorine now. I've got 2 here, and 2 times that 1 is 2 fluorines, so it's correct. It's nice and balanced. So now what I want you to do with your periodic table, because you can't do it without your periodic table, I want you to simply say whether there will be a chemical reaction for these. Right. Now, I want you to do a few things actually. Let's do this. So, number 1, I want you to write in the table, so you should have copied this table down, and say whether there will be a chemical reaction or not. So write, yes, there will be a reaction, or no, there will not be a reaction. Don't just do a tick or a cross, because that won't make sense to you, especially when you're revising. And then the next task is you're going to write the word equation for each one, and then the chemical equation for each one. Alright, so pause the video, see if you can do that, and then we'll go through it together. So here with fluorine and fluoride, there's going to be no reaction because it's the same thing. Right. Can chlorine, the question is, can chlorine displace the fluoride? No, it can't. No reaction, because remember, the fluorine is the one nobody can mess with, so no reaction. And is that fluorine is the most reactive. Now here's the question, can fluorine displace the chloride ion? Yes, it can. Well, there's gonna be no reaction here because it's the same thing. Bromine and chloride, can bromine displace chloride? The answer is no, and the reason is because bromine is lower down than chloride, so therefore chlorine is more reactive, so it cannot be displaced by bromine. Can iodine displace chloride? And the answer is no. Now let me go back to the periodic table just to show you. Here's iodine, here's chlorine. Can iodine displace chlorine? The answer is no, because chlorine is more reactive than iodine. That's just to show you, so no reaction. So like I said guys, you need to have a periodic table just to double check your answers. So can fluorine displace the bromide ions? Yes, it can. Can chlorine displace the can chlorine displace the bromide ions? Yes, it can, because it's higher up. The chlorine is higher up, therefore it can displace it. There's going to be no reaction here because it's the same thing. And can iodine displace bromine? So what we're asking is, can iodine... So what we're asking here is, can iodine displace bromine? The answer is no, because bromine is more reactive than iodine. And the poor one that gets bullied and everyone can displace it because all of these are higher than it is poor old iodide. Iodide, if you think about it, it's the one that's gonna be died. Yes, quite. So iodide is gonna be displaced by all of these. So if you think about it, if fluorine is the one you can't F with. Iodine is the one that died. Do you get that, guys? It's the one that died. D-I-D-E. Like, you know, died. Like. So if you haven't done it already, try and do these equations, because in a couple of seconds I'm just going to put the answers up and see if you got them right. If you have, well done. If you haven't, look at mine. If you have any questions, you can ask in the comment section below. So check your answers with the word equations that I've made, and remember, the only one that can have an equation is where there will be a reaction. Now, I made a mistake earlier. I kind of said that potassium iodide would react with potassium iodine. Potassium iodide will react with iodine, but that's not the case, because it's the same thing. There will be no reaction because it's the same thing. Iodine, iodide, same thing. Okay. So have a look, pause the video, check your answers with these answers. Then once you've done that, pause the video, go back to the beginning of this tutorial if you have to, and see if you can do a video. See if you can do a answer with all the chemical equations for all of the ones with reactions. So pause the video, do that. When you unpause it, you're gonna find the answers there, and just compare your answers with mine. Okay, so I've written my chemical equations underneath my word equations. That's so that I can constantly refer back to the word equations. And so I've got KCl, which is potassium chloride, plus my fluorine, which is from group 7, so it's diatomic, which makes my potassium fluoride, plus my chlorine gas, which is diatomic once again. And look back at the earlier part of this tutorial, but to balance this you put a 2 in front of there and a 2 in front of there, and so to balance all of these you do the same. Now just double check your answers with mine, pause the video if you have to, see what you got, see what I've got. If you do have any question, like I've said, just make sure you ask in the comment sections below. And if you don't have any questions, then that's brilliant. Well, it's brilliant so long as you've understood it. Now, so yeah, pause it, have a look, give yourself a pat on the back if you've got it right. So our final learning objective is going to be to explain why fluorine. So our final learning So our final learning objective is to explain why fluorine is more reactive than iodine. And to do this, we're going to use the two examples, which are fluorine and chlorine, because all we need to do is to show an understanding of the trend as it goes down, and the same answer will apply throughout. So if we look at fluorine, I'm just going to write this here. Fluorine, we want to look at the electron structure again, so we're just going to write 9. We're not interested in the top number for this because we just want to know about the electron. And if you remember, the bottom number represents the electrons, well, it represents the protons, which happens to equal the number of electrons. And with chlorine, the bottom number is 17. So let's draw fluorine first. If you have a look at fluorine, now guys, with these questions where they ask you to explain the trend for group 1 and group 7, I recommend drawing out the electron structures so that you kind of have something to refer to, and it'll help your explanation. So it's 9 electrons in total, so it's 2 in the first shell, because that's the maximum you can have. Then it's going to be 7 plus 2 is going to make 9. I know that it should have 7 electrons in the outer shell because fluorine is in group 7. So I've got 7 on the outside and 2 on the inside. That's 7 and 2, which makes 9 in total. Now here I've got chlorine, which is 17, so it's 2. I know that the second ring needs to have a maximum of 8, so every other ring has a maximum of 8 except the first one, which has a maximum of 2. Now if I say, so here I've got 2 on the inside, 8 on the outside, so that's 10 in total, and so I need 7 in the last ring. 1, 2, 3, 4, 5, 6, 7. Right, so the electronic code is 287. So because there's 7 in the last shell, that kind of gives me a clue that I'm right, because, or that I've drawn it correctly, because chlorine and fluorine are in group 7, so they should have 7 electrons in their outer shell. And so it's 2, 7. So you see how I wrote 7, 2, and then I looked back at it, I double checked my work, and I know that the last number has to be 7, so that's clearly wrong. So it's 2, 7. So do double check your work. There's another lesson for you. So the question now is, why is fluorine more reactive than chlorine? You can answer this question in the following ways. Number 1, they are non-metals. They are non-metals. Right. Number 2, non-metals accept electrons. Right. Number 3, the distance between the positive center, between the positive nucleus, the positive, that's short way of writing positive, nucleus, and the outermost electron is smaller for fluorine. So if you look here, remember this is a nucleus, so it's positively charged, these electrons are negatively charged. Look at this distance here, right? It's very short. So because of that, they're going to be stronger attraction. It's going to be stronger attraction between the positive center and the negative electron. Whereas look here, you've got a positive center and the negative electron, and the distance has increased, so it's going to have less attraction. So it's going to be less attraction. And remember, these want to accept electrons, so it's going to be harder to accept electrons. It's going to be harder for this compared to fluorine. Chlorine is going to find it harder to accept the electron because the distance between the positive center and the outermost electron shell is further away. Next, the next reason that you need to be aware of, so that's kind of like point 3, I explained a bit more, so we can kind of say this is point 4 because really that is point 4. Number 5, the 5th point, is the number of electron shells. So if you look at chlorine, it's got 1, 2, 3 electron shells. So the electron shells provide shielding, right? So in other words, chlorine has more shielding than fluorine. So the attraction between the positive center and the outermost electron shell is weaker. So you guys finish that sentence because I've run out of space. So what we're saying is that because there's more shielding, 1, 2, and then the third one, this here is going to stop or decrease the effect of the positive center having attraction to the outermost electron. Whereas here, if you look, there's only one shell and then it's the next electron shell. So because there's less shielding, it can attract that extra electron much more strongly, whereas here the attraction between the electron is going to be weaker. Why is it weaker? For 2 reasons. Number 1 is the shielding, and number 2 is the distance between the positive center and the outermost electron shell. So you can apply this logic to all of them basically. So if they ask you why is fluorine more reactive than iodine, it's the same thing. So if they ask you, for example, why is fluorine, they could ask you why is bromine more reactive than iodine. It's the same principle. Okay, so number 1, so if we're comparing bromine with iodine, let's make them halogens, right? In fact, if we're comparing bromine with iodine and we're saying why is bromine more reactive, then it's number 1, bromine has less shielding, right, compared with iodine. So that's a short way of writing compared with iodine. Therefore, that's a short way of writing therefore. Therefore, it has a stronger attraction to the outermost electron shell. So I've not said what it is, don't ever do that. So it, what do I mean by it? The positive center, the positive nucleus. The positive nucleus has a stronger attraction to the outermost electron shell. So that's number one. Number two is bromine has less distance between the positive center and the outermost nucleus. Did I just say the outermost nucleus? What the heck? And the outermost electron shell. And so this means bromine will have stronger attraction compared with iodine. And that sums it up, guys. That sums it up really well. If you do have any questions, ask in the comments below.